Okay, let's quickly go through step one, the exploratory data analysis. So we've done most of that already in the last lecture, and I won't dwell too much about it. You just, when you load in a data frame, you look at its structure, what data types do you have, what are the categories, which cancer types in this data set, for example, how many cell lines per cancer type, things like that. We can have a look at the distribution using histograms. We can analyze our gene of interest a bit more. What is the spread of dependency? What is how dependent is it overall? Is it more dependent in one cancer type than in the other? Things like that. But one thing I will show you in a little bit more detail is the missing values. You, if you want to do statistical tests like Pearson tests and things like that, especially with SciPy, the data must not have any missing values. If you have missing values in your data set, the programs will crash. So we have to deal with this in some kind of way. And there are several strategies. The first thing is you have to decide how much missing values do I want to tolerate. And if you're above a certain threshold, like 20%, for example, so if you look at a column and more than 20% of the data missing in that column, you just delete that column. Same with a row. If a cell line has more than 20% missing data, you delete that cell line. And um, you basically do yourself a favor. You lose some data, but you also lose a lot of noise. Um, However, we won't need to do that. I'm only introducing a few missing values into the data set so that you can practice the impute method, because I think that's the more important one. Um, so basically what we have to do is we have to see which genes have missing values, and then we have to make a decision what we're going to do with those. And there are different methods to deal with missing values. The most common one is that you calculate the median of the column and then just introduce the median. So statistically, that's most of the data will cluster around the median if the data are normally distributed. And so you have a good chance to hit, just to put the median number in there, that you're not messing up the data too much, and you're just bypassing that missing value with a educated guess. You can also use the mean, but that's more sensitive to outliers. If you have a series of data, like a time series, for example, it would make sense to use forward or backward fill. So use the next value or the previous value, because that will be the most similar in the data set. So you can use that information. Another option would be to fill constant values in. And so basically first you see how many, and if there's too many, you delete the column or the row. Uh, then you see is it time series data or any kind of serial data, then you use forward or backward fill. If it has outliers, use median, but I would use median anyway. That's usually the most robust way of dealing with it. Um, so we only have a few genes in the dataset that have introduced missing values, and we use a median impute. So we calculate the median of the column and add this in. So I'll show you this in a notebook. So first, this first function, so I've separated everything in function. This is quite a good thing to get used to, even though, you use this code only once, maybe in this notebook, but then it's still easier to copy it out and use it on another gene. You only have to change the parameter when you call a function and not write all of this again. So it is good practice to keep your major things in function. So here we're just separating the numerical values from the metadata columns. And then we're doing a missing value analysis. The first thing is we're checking how many missing values do we have. So we use this is_null method and sum. So I can show you this quickly. Let me just introduce a coding frame here. So we can say df gene dot is_null and then dot sum. And that will give us, oh, not GF, but DF, sorry. That will, oops. Oh, it's gene DF, I'm sorry. You see? You have to keep track of your variable names. So gene DF is not. Then you're getting for each column, you get how many missing values do you have, and you could separate here to just the numerical values as well. If you do another sum, it will sum up this row that you see here, and it'll give us the total value. So we have 5. This is a number, it's an MP number, so don't worry about this data type, but you can use it as a normal number, and it's the number 5. So we have 5 missing values. And if you go through the rest of the code here, it calculates the percentage overall and which columns missing value, in which genes have missing values. And then the next function here is the impute, where it will calculate the median of the column. So it goes through the data frame. If the column is if the sum of the ISNA in the column is greater than 0, then you can either impute the median or the mean in this function, but the default is the median. And if you run this function, give it the GDF, the numeric columns, and the method median, you will impute the median value and replace the missing value with the median value. And then if you run it again, you will not have, if you run the sum analysis again, you will not have any, so here in the end, we're checking how many missing values have we got left at the end, and we're not having any missing values left. And that's basically it for missing values.